Hello everyone. So this is the 8th session of the Advances in Food Analysis, and the topic which we'll be covering today is STEM, that is Transmission Electron Microscopy. So electromagnetic lens, that is the objective lens or the aperture. Since the electrons coming from the electron guns have spread in the kinetic energies and direction of movement, they may not have focused to the same plane to form a sharp spot. By inserting an aperture, the stray electrons are blocked and the remaining narrow beams will come to a narrow disk of least confusion, as shown in the figure below. The electron solid interaction. Now, when an electron interacts with a specimen, when an electron beam strikes a sample, a large number of electron signals are generated, such as incident electron beam is interacted with the sample. Then there are backscattered electrons. There is cathode luminescence. There are secondary electrons, and we can divide the signals into two broad categories, that is electron signals and photon signals. A transmission electron microscope is analogous to slide projector as shown in the figure below. The transmission electron microscope consists of the electron optics, the instruments, the image contrast, that is mass thickness contrast or diffraction contrast or phase contrast, and specimen preparation. In a conventional transmission electron microscope, a thin specimen is irradiated with an electron beam of uniform current density. Electrons are emitted from the electron gun and illuminate the specimen through a two or a three-stage condenser lens system. The objective lens provides the formation of either image or diffraction pattern of the specimen. The electron intensity distribution behind the specimen is magnified with a 3 or 4 stage lens system and viewed on a fluorescent screen. The image can be recorded by a direct exposure of a photographic emulsion or an image plate or digitally by CCD camera. The acceleration voltage of up to date routine instruments is 120 to 200 kilovolt. Medium voltage instruments work at 200 to 500 kilovolt and provide a better transmission and resolution. And in high voltage electron microscopy, the acceleration voltage is in the range of 500 kilovolt to 3 megavolt. Acceleration voltage determines the velocity, wavelength, and hence the resolution of the microscope. Depending on the aim of the investigation configuration of the microscope, transmission electron microscopy can be classified as conventional transmission electron microscopy, high resolution electron microscopy, analytical electron microscopy, energy filtering electron microscopy, high voltage electron microscopy, dedicated scanning transmission electron microscopy. So this is the basic difference between SEM and TEM. The electron source passes through the condenser lens, then there is an object and an objective lens. There is a first intermediate image which is clarified after the intermediate lens, and finally it is processed on the projector lens, in which we get to see the image or a diffraction pattern. The TEM consists of the following major parts, that is the illumination system, electron guns, condensers, the image forming system, that is the objective lens, the projective system, that is several projector lens, and an aperture affect the formation of image and diffraction patterns. Electron gun. This is a schematic diagram of an electron gun. A high voltage is placed between the filament and an anode when a potential on the Wernelt which acts to focus the electrons into a crossover with diameter d0 and convergence upon divergence angle alpha 0. That's all for this session. Thank you.